In the previous class, we discussed about bounded sequence, supremum and infimum. Today, we discuss about limit of a sequence. Limit of a sequence. So, limit of a sequence means a sequence xn be a sequence and L belongs to a real number or the real number L is said to be limit of the sequence xn if for each epsilon greater than 0 there exists a positive integer m such that modulus of xn minus l is less than epsilon for all n is greater than or equal to m. So which implies that limit n tends to infinity xn is equal to l. Here l should be a finite. If it is finite, it is a convergent sequence. It is infinite, it is a divergent sequence. You have to remember, see once again, limit of a sequence is that the real number L is said to be limit of the sequence xn if for each epsilon greater than 0 there exists a positive integer m such that modulus of xn minus l is less than epsilon for all n is greater than or equal to m. That is, it implies that limit n tends to xn is equal to m. It is converted to a finite limit. So you have to remember that definition we use from of the theorems. Definition of a sequence. ಕೆಲವು theorems ಗಳಲ್ಲಿ ನಾವು ಈ definition ಯೂಸ್ ಮಾಡ್ಕೊಂತೀನಿ. You have to mainly remember for each epsilon greater than 0 there exists a positive integer m such that xn should be xn minus l is less than epsilon for all n is greater than or equal to m. Here limit n tends to infinity xn is equal to m. Okay, so this is the limit of a sequence. Let us move on to one theorem on the limit of a sequence, that is every convergent sequence has unique limit. Every convergent sequence has unique limit. Let us assume that this is a theorem. Every convergent sequence has unique limit. ಅಂದರೆ ಪ್ರತಿಯೊಂದು convergent sequence ಅಂದರೆ ನಿಮಗೆ ಗೊತ್ತಿದೆ, it should be converges to finite limit, but it has a convergent sequence ಆವಾಗಲೇ unique limit ಅಂದರೆ ಸಿಂಗಲ್ ಒಂದೇ ಒಂದು ವ್ಯಾಲ್ಯೂ ಇರಬೇಕು. unique limit means single, that means only we get only one value for a very convergent sequence. Let us assume that sequence xn converges to two distinct real numbers L1 and L2. Since L1 is not equal to L2, so assume that first time assume ಮಾಡ್ಕೊಳ್ಳಿ sequence xn converges to two distinct, here distinct is important, distinct real numbers L1 and L2. L1 ವ್ಯಾಲ್ಯೂ ಬೇರೆ, L2 ವ್ಯಾಲ್ಯೂ ಬೇರೆ, ಹಾಗಾಗಿ L1 ಮತ್ತು L2 ನಾಟ್ ಈಕ್ವಲ್ ಆಗುತ್ತೆ. ಸಿನ್ಸ್ L1 is not equal to L2 ಆಗಿರೋದ್ರಿಂದ, ಅಂದರೆ ಎರಡು ಸೇಮ್ ವ್ಯಾಲ್ಯೂ ಇರೋದ್ರಿಂದ, ಇಟ್ ಇಂಪ್ಲೈಸ್ ದಟ್ modulus of L1 minus L2 should be greater than 0 should be positive. ಅಕಸ್ಮಾತ್ L to the 2 ಆಗಿ L1 1 ಆದರೆ 2 minus 1 is 0. Modulus ಹಾಕಿದ್ರೆ should be a positive value get the positive value for a convergent sequence which is a greater than 0. Since convergent sequence ಗೆ ನಾವು ಪಾಸಿಟಿವ್ ವ್ಯಾಲ್ಯೂನ ತಗೊಂತೀವಿ ಒಂದು. Since L1 is not equal to 0, L1 minus L2 is greater than 0. Okay. So by definition of limit of sequence, by definition of limit of sequence for every epsilon greater than 0, limit of sequence, if sequence xn converges to L1, then for every epsilon greater than 0, there exists a positive integer m1 such that definition of sequence ನಾನು ಹೇಳ್ತಾ ಇರೋದು xn minus L1 is less than epsilon 1 by 2 for all n is greater than or equal to call this as equation 1. So by definition of limit of xn, if sequence xn already L value ತಗೊಂಡಿದ್ದೀನಿ, if sequence xn converges to two distinct real numbers L1 and L2, if sequence xn converges to L1, by using definition of limit of sequence, for every epsilon greater than this, there exists a positive integer m1 such that modulus of xn minus L1 is less than epsilon by 2. Similarly, if sequence xn converges to L2, by definition of, again by using definition of limit of sequence, there exists a positive integer m2 such that modulus of xn minus L2 is less than epsilon by 2 for all n is greater than or equal to m2. This is m1, this is m2, or this is equation 1, 2. So first of all, we assume that the sequences converges to two real distinct elements L1 and L2. Therefore, L1 is not equal to L2. That means modulus of L1 minus L2 should be greater than 0. So we can consider ಮಾಡ್ಕೊಂಡಿದ್ದೀವಿ ನಾವು by if sequence xn is convergent to L1, and for every epsilon greater than 0, there exists a positive integer m1 such that xn minus L1 is less than epsilon by 2 for all n is greater than or equal to m1. Similarly, if sequence xn is converges to L2, okay, by using definition of limit of sequence, again modulus of xn minus L2 is less than epsilon by 2 for all n is greater than or equal to m2. So here we get a different integers m1 and 2. Let us choose m is equal to maximum of m1 comma m2. Maximum value choose ಮಾಡ್ಕೊಂತೀವಿ ಇಲ್ಲಿ m1. So therefore equation 1 and 2 becomes xn minus L1 is less than epsilon by 2 and xn minus L2 is less than epsilon by 2 for all n is greater than or equal to call this as equation 3. So this is by using definition we are choosing m is equal to maximum of m1 and m2. That's why we write as for all n is greater than or equal to m. So next, consider modulus of L1 minus L2. So here we are going to prove that L1 is not equal to L2. We are assumed, but we are proving our assumption is wrong. L1 is equal to 2. Inequal limit means L1 must be equal to L2. That's why we are considering modulus of L1 minus L2. Here add and subtract xn and xn minus L2. So it is equal to modulus of L1 minus xn plus modulus of xn minus L2. By using the property of modulus property, if we split into two parts, linear property we get here less than or equal to L1 minus L2 is less than or equal to this one. So which is less than or equal to, since modulus property, we get a positive sign, modulus of xn minus L1 plus modulus of xn minus L2. By using this equation 3, xn minus L1 is less than epsilon by 2, xn minus L2 is less than epsilon by 2. Therefore, in order to less than or equal to, we have to write less than epsilon by 2, less than epsilon by 2. So that is, consider modulus of L1 minus L2 is less than epsilon by 2 plus epsilon by 2 for all n is equal to greater than L1 minus L2 is less than epsilon for all n is greater than or equal to m2, which implies that again by using definition of limit of sequence, this can be written as n into infinity L1 is equal to L2, which implies that L1 is equal to L2. Therefore, our assumption is wrong. Therefore, our assumption is wrong. What is our assumption? L1 is not equal to L2 is wrong, which implies that every convergent sequence has unique limit. Please remember this theorem. Every convergent has unique limit. Thank you.